Hello everyone, welcome to our pre-calculus pre-recording video. This is about logarithmic functions, and these are the agenda. We have what is logarithm, converting between exponents and logarithms, evaluating logarithms, logarithmic functions, solving the logarithmic equations. So before we begin to detailed discussion, let me give you an announcement, and this is about our quiz 3. Quiz 3 is coming up, and quiz 3 is, the date is actually this Thursday, and the syllabus will be so far the thing that we have discussed after the break. Okay, so these are the things that will be included in our, including this lesson also, of course. And by the way, no worries, we will give you all the practice paper. From there you will get more clearer sense what is going to happen, what will happen. Also, we have a practice class also. Wednesday will be that class. Okay. So these are the agenda for this lesson. Let's discuss first of all exponents and logarithms, how they are related, how they are connected. Okay. So this exponent, this exponential function, exponent, this kind of things is basically this kind of things are basically, you have the idea. So let's say if I write 2 cube, so 2 cube equals to what? 2 cube means basically 8, right? 2 into 2 into 2. 2 cube means this. So 2 to the 4, 4 into 3 equals to 8. 2 cube, it means 3 copies of 2. 3 copies, 1 copy, 2 copy, 3 copy. 3 copies of 2. This is what 2 cube means. Alright. And this is, of course, this is exponential kind of, when you have, since you can change this, if you change this number, let's say you change it, then it becomes 16, then you change it, and then it becomes 32, kind of this and that. Now, in the logarithm, what will happen is, this base will remain the base, and this answer thing will come here. This is the answer. Answer will come here. And then you will be asked to find out the answer from here. So what is the answer? The fun part is, answer is actually 3 here. And how do we know that answer is 3, or what is the proof, how it works? The system, how it works is, when you have a base and some number here or something here, the question that you should ask is, or you should ask is, what is the power of this number which will make it 8? Or what power, in this case 2, what power of 2 will give us 8? We have 2. What power of this 2 will make 8? Answer is 3. This simple. Logarithmic function is this simple. So in this case, what will happen? Log base will remain same, answer comes here. So if the question is this, what is the answer? 2 to the power what equals to 4? 2 to the power 4 equals to 4. And same thing will go about this, and the whole entire maths, entire systems, everything will work this way. Okay, everything will work this way. And in the reverse order, if it is given like this, say log 3 base 27, this equals to what? I think now you know the answer. 3 to the power what equals to 27. So answer, you will know the answer. Now, if we want to convert it to this exponential something, then how do we do it? So our base will remain the same, 3 to the power. Let's say this equals to what we do not know, suppose this is x. Suppose we do not know this equals to what? This equals to x. So what can we do about this conversion is, we know that the answer, this 8 actually goes here. So basically this 27 is the answer. That means we'll write 27 equals to. Then this base remains the base always. Base never changes, because you see the base is here 2, base is here also 2. Base is here 2, base is here also 2. Okay, base never changes. In this math, base is 3, so base will remain the same. Okay, and then this thing here will become the power. How do you know? We know it from this, because you see log 2 base 16 equals to 4. Let's say 4. Then what happens here? This conversion is 16 equals to 2 to the power 4. So this number goes up. This number goes up. Okay, sorry about that. And then we have so here this x will become the power, and since it is a variable in the power, so it is basically an exponential function. And how do we solve it from here? 3 to the power x. This 27, so this means 3 to the power 3. Base same, so x equals to 3. This is how also you can solve it. If you do not want to solve it by using the analysis or thought process, you can solve it that way also. Okay. All right. And of course, many maths we will have to solve it by considering this procedure, or because there will be like a couple of things involved, not only just number and number. Okay. So now let's look at how it happens. You know, exponential and logarithm, they are just like inverse function. And that is the reason why I discussed inverse function in between. So when you have some exponential function y equal to the power x, logarithm should be something like, instead of y it should be x, instead of x it should be y now. Because inverse, the reason is inverse, they are inverse of each other. And then what can we do is, we can write in the, this is written in this is the notation system, this is written this way, just like you have seen this in the example that we have given you. When you have 2 to the power 3 equals to, let's say, 8, so how do we write it? We write it log 2 base of 8 equals to 3. So this power thing goes to the other side. So what we have here in the power, so this will go to the other side. Already it went there. And this number here comes here. So that is the reason why you can see this x came here. Okay, like from this line to this line. When you have y equals to the power x, first of all you just interchange x and y, because this is due to the properties of exponential and logarithmic, they are inverse of each other. That is the reason. Now for conversion, you will write log, first of all, a base, and this answer equals to y. Okay, this is the conversion system. This is more fluid. I mean, this way it is more fluid. Then you can write y equals to log a base x. That is also fine. And the condition, as usual, you know, to make the function valid, we need some conditions, so that we do not run into undefined or unsolvable situation. This is once again with more clearer example. Example 8 comes here, 2 becomes the base, 2 is the base, and the power goes to the other side. And once again, this is the repetition. So we are saying that what power of base A produces this number? Like what power of this 2 will produce this number 8? So answer is 3. Log basically does this function, does this thing. Here you have we have a lot of exponential to logarithmic conversion. When we have 3 to the power 4 equals to 81, how do we convert it? 3 to the power x equals to this, how do we convert it? All these things. Okay. So this is the conversion, how this form to this form we can go. And then you will try to do this conversion. This is easy basically. This is super easy kind of. If you want to solve a couple of them, suppose 10 number, this is like 16 equals to 4 to the power this 2. So how do we convert it? First of all, we write log base will remain always the same, then it is 16 equals to 2, this way. Suppose if we want to convert it, so log, what we will do, base is here, so base will always remain the same. This is m equals to 2.2. I suppose this is m as it is looking from here. Okay. Then we have here, let's say 22. How do we convert it? This is given log 2 base 6 equals to x. So when you have something like this, there is a trick kind of. Keep this 6. Do not move this 6. 6 right first, then you go to the other side, then bring the base 2 and move it to the power. Okay, this simple. For example, this math. First of all, keep this 2 here. Do not move it, this 2. Then this equals to keep the base here, then just move the power up. Okay. This is given ln of 4. Ln 4 means log e base 4. Log e base 4 of 4 equals to x. So how do we convert it? So we can convert it to like the same method. So first write 4 equals to e to the power x. So if they write ln, suppose ln 2 means log e base 2. Okay, e base, log e base means ln, ln. This is ln. Okay, this is log e base means ln. So there is 2 special case in logarithm. Let me write them here. One is this ln thing, another one is log thing. Suppose if someone write log 5, if someone write ln 5, if someone write log, let's remove it, then write it again, log, suppose 3 base, this is crazy, okay, 3 base 5. So what is that difference? In most cases, you will see that the base is given. This base is given. In most cases, you will see that. See, this math base is given. See, this math base is given. Base is given. Base is given. Base is given. Here it is A, but it is given. Here it is B, base is given. Only in 2 situations, they will not give you the base. This one and this one. This is log 5, ln 5. Now you can say, will it be log 5 here? No. It can be log 10, log 20, log 50. It means that the base is 10. If they don't tell you what is the base, that means base is 10 always. And ln means log e base. If the base is e, that means then it means that log e base means ln. This e is the same number that we have learned, 2.718, that constant number. So that exact same number. So this 2 is the special case that we should keep it in mind, that sometimes in the book, sometimes in the worksheet, or even in the maths, they may not write it what this ln and log, only log is about. Okay. Other things always the base will be given. So if the base is given, then we can just consider that base. If the base is not given, then actually it is something that we should be very careful about. It's not like a mistake in the question, because this is not, suppose ln 4, it's not a mistake in the question. Ln 4 means log e base 4, then equals to x or whatever it is, this and that. And in your calculator, this is so important. That's why it is written once again here. In your calculator, you have that log button and ln button. Okay, this is the ln button task, and this is the log button related thing. So this log means, as we said, log means log 10 base. 10 base. Calculator automatically understands this. This is how calculator is programmed. Okay, this is how calculator is programmed. If the base is not given, then calculator thinks that the base is 10. If the base is not given, and this button actually, in this button actually you cannot give the base. Calculator will automatically take it as 10. So let's say log 10 base 100 equals to 2. How it comes? The same way. What power of 10 makes it 100? What power of 10 makes it 100? Answer is 2. 10 square equals to 100. Okay, that's why it is 2. Then we have some few more here. So we have ln 1. This is a little bit crazy. Then we have, okay, ln 1 means what? Log e base 1. Ln means log e base 1. So how it comes 0? This is important. Look at this carefully, because this kind of thing will come again and again. This is important. Why it is 0? Why it is 0? The reason is, think about it. What power of e will make it 1? What power of e will result in 1? Say, suppose e to the power 1 equals to e to the power 2 equals to e square. E to the power 0 will make it 1. That's why answer is 0. And why I said this is important, and I said that look at this carefully. The reason is, see, this is not only true for e to the e base 1, it is true for anything. It is true for anything. Let me show you that, okay? Suppose if I say log 2 base 1 equals to what? So what power of 2 will give you 1? Answer is 0. This equals to 0. So log 10 base 1 equals to what? Answer is 0. Log a base, this is the formula now, a base 1 equal to what? Answer is 0. Do you understand? If you see 1 here, answer will be always 0. Because all these things to the power 0 equal to 1. That is the reason. This comes automatically. The remaining is easy. This comes automatically. Ln means log e base. Ln means, this is the value of ln, only ln. Then there is a e here. So let's write e equal to what? What power of e will make e? 1, right? Because e to the power 1 equal to e. So answer is this. This power is the answer. Exponent is the answer. Power is the answer. And the name is indices. Index. This index. This is another. They have some always different names, and we should know all of them. So e to the power 1 equals to e. Okay, that is why it is e. Oh, this one is more funny. Let's have a look. This one is more funny. And actually a little bit important also. This said that this equals to 2. So log e base e, then it's square. We have a lot of things going on here. So one of the rule in logarithm is when you have e squared, already base is already given, then this power will come back here. This power will come back here. That means it will become 2 log e base e. And e base e equal to 1, so basically it is 2 into 1. 2 into 1 equals to 2. This power shifting rule is also important. Keep it in mind. You will need it for problem solving. Log 1000 equals to what? We can do them. 1000, 10,000. Same way, you just have to do a little bit more. This is how we can change the base from one base to another base when your calculator do not have something like all the different bases. If the calculator do not have, then how do you solve it? What does it mean? Let me give you a very clear example. Suppose we ask you to find out log 3, very difficult, let's say 3.5 base, let's say 4.258. Suppose this equals to what? Now see, the way we used to think what power of this will make it that will not work here. I mean, unless you are a math genius, I mean, a different level math genius. This is even, genius will even have some trouble to solve it. Because the power, what power of 3.5 will make it this? How do you do it in the calculator even? So what should you do is use this formula here. In the calculator, you should press like this. See this m here, it goes up. That means this number will go up. In the calculator, you will first find out log 4.258 divided by log 3.5. Then you press equal to, calculator will give you the answer. Then the answer is correct answer. You even do not need 3.5 to write as a base because we used the conversion formula. And this works even for the ln also. You can, instead of log, you can press ln this divided by ln this. Answer will be same because there's that finds the relative value. So the answer will be same. This one is also super important. Super means this is really, really important. It will save you from many trouble. This process. So what should we do if we see something crazy in the maths, something that we cannot find out from our analysis? Then what should we do is we just write log this divided by log this in the calculator. All the calculator, ordinary calculator, I have exactly this one. Okay, all the ordinary calculator have this button. Ordinary means minimum scientific calculator where there is some log button. Log button means actually you have this button here. You have this log button. All of them have this function. So you can use this to find out the solution. They have some special name, by the way. This is when base is 10, this is called common logarithm. When the base is e, this is called natural logarithm. They have a special name, fancy name, people have different names. This is natural logarithm. This is common logarithm. 10 base when it is base is 10, common when it is base is e, then it is natural logarithm. This is an example here. Check this math, okay? Do this math in your free time and check if you get the same answer or no. Check it if there is any mistake in the answers. All right, so now how do we solve it? How do we solve different equations? How do we solve different equations? This is easy. These are from the book. As you can see, when you have e to the power, let's say e to the power twice x equals to 5. So how do you solve it? You multiply both sides by. So this is e to the power twice x equals to 5. First of all, we can actually multiply both sides by ln. This will help us. So if you take ln e to the power twice x equals to ln 5, ln and e will be cancelled out. This will be cancelled out. We can write it this way: twice x, then ln e equals to ln 5. Then ln and e equals to 1. That means twice x equals to ln 5. So x equals to what? Ln 5 divided by 2. Why ln and e cancels out? The reason is this: ln e. Ln e means log e base e. Cancel out means this basically is 1. This is how, that's why it all of a sudden evaporates from here. Evaporates, you know, it becomes air. So it goes out this way. Then ln 5 divided by 2, you do it in the calculator. Calculator gives us this answer. This one is, so this first line comes from the conversion. When you do the conversion, you know that this number will remain here, base is 2 and power goes there. And the remaining thing is, I think, super easy. Just this is 8 minus 1 equals to 2 twice x. So x equals to 7 divided by 2, so that must be 3.5. This is what? So it will be 1 by 8 equals to, base will remain the same. This is the base, power is 3. This is crazy. So what can we do here? This is actually 1 divided by 2 cube. So this equals to x cube. So both sides you have the same power, so x must be equals to half. X must be equals to half. Okay, so this is done in this way, and then we have done it slightly differently. We have done it, okay, here on screen. So let's see. So here we have a little bit more. One of the formula actually you already have seen here. This is log a base a to the power r equals to r. Okay, this formula we already slightly talked. This is log a base a to the power r. This is a formula. And how it works, the reason is log a base a. Then this r comes to this side because this is the power. So you have r, then log a base a equal to 1. So basically it is r. It is 1. This way it happens. This happens, the reason is this is by using the inverse function property. It happens when you have the same base to the power log a base m. When the base is same, you can eliminate them, and the thing only remains is m. This number, whatever it is. When you have same base, this is a to the power log a base n. The quantity is like that. Okay, this is this thing is power. Okay, this thing is power. So once we have this e to the power twice x ln, we take this kind of this one. Actually, you have seen solving it. Let's solve some bigger math, something little bit big. So we have here different types of maths. Let's say this math looks big. So this math is so the rule that we are following is first we write 243, then we do like, okay, base always remain the base, and then this becomes twice x plus 1. It goes to the power. We are solving 97 here. Now what cube equals to 243? It must be 7. 7 cubed equals to 247. So 3, 2. Oh my god, this is crazy. 7 cube equals to, but this is not giving us same base. Okay, let's see. 81 into 3 equals to what? 81 into, oh, 81 into 3 equals to, 81 into 3 equals to, I think, 243. Yeah, 81 equals to 3. See, this is correct or not? 243. Oh, this is 343. 343 is actually 247. 3, 216, 343. Yeah. So 7 cube means 7 cube means actually 343, not 243. Okay. And even if it is 243, still this math will not work because the base is different. We have to make the base same. Okay, we have to make the base same. So let's bring the eraser and let's erase it, and let's write it here because we have to make the base same. So 3 base same. Base means 3. Here base must be 3. So first of all, 3 into 3 equals to 9. 3 into 3 to the power 4. 3 to the power 5. So it looks like 3 to the power 5 equals to 243. Let's do the calculation again. 3 to the power 3, 27, 4, 5. Yeah. So this. So same base when you have, then base cancel out. Then you write twice x plus 1 equals to 5. You do in the calculator. Suppose you have to do it in the calculator maybe. So 5 minus 1 equals to 4. Then x equals to 2. This is the answer for 97. Okay. All right. Let's do a very easy math. Okay. Let's do very easy math. Suppose 88. Very easy. What should we do? Oh my god, this is so hard. Log 5 x equals to 3. So x equals to what? Base will remain same, then it must be, it goes to the power. X equals to, base will remain base, this will go to the power. Just do not move it. Do not move it. Then you will get some strong hinge if you want to do the calculation. 5 cube means 125. This is the answer. This is very hard math. Huh? Okay, let's do another little bit difficult one. So let's say 104. I think this one looks a little bit bigger. Yeah, this one looks bigger. This one looks bigger. So how can we solve it? So x squared plus x plus 4 equals to 5 squared. Because base will remain the base, and you know, this goes to the square. This becomes the square. So you have x squared plus x plus 4 equals to 25. Then we have x squared plus x plus 4 minus 25 equals to 0. Yeah. Oh my god, this is x. Okay, so x squared plus x minus 21 equal to 0. How can I factor it? How can we factor it? Is it possible to factor it? Is it possible to factor it? So 21, I think there is no other factors. By 2 it is not divisible. So 3, 7, both of them are prime numbers. So I am in little bit trouble because both of them are prime number. So let me see if I can do the factoring in some other way. So if we cannot do the factoring, middle term factor, then let's see if there is actually solutions or not. B square minus 4ac. So b value is 1 minus 4ac minus 21. This equals to 1 minus minus plus 4, 8, 85. There are solutions here. That means we have to continue. So this, remember this word, this thing, this is 85. Let's check it again. 1 square, then 4 ac, 4 ac. ac means minus 21. Minus minus plus 84. 84 plus 1 equals to 85. So this is 85. B square minus 4 equals to 85. We will have to keep it in mind because we will use the quadratic formula and this term will come there. Formula is minus b plus minus a square root of b square minus 4ac divided by twice. This math is, although I have taken it just for fun, but this math is really big as it looks like. But it's fun, you know. This is fun. So minus b means this is 1 here. Plus minus, why I said keep it in mind, because you see b square minus 4ac is same thing, so basically we will write here 85. So root 85. You understand? If we put all this thing, we will get 85. Then twice it, so 2 into a equal to 1. So twice a is 1. Now what can we get? Oh my god. What can we get from here? So this is minus 1 plus minus 85, root 85. Root 85 is crazy. Root 85, can we factor it in some other way? Let's check. Is it divisible by 3? So if I try to divide it by 3, so it becomes 225. No, not divisible by 3. So is it divisible? 4, no, 5, yes. So 5. 117. Not 17. This is, oh yeah, 17. And both of them are prime numbers. So basically this is not helpful. So we have, I think this is the answer then, because we cannot move any farther. We cannot move any farther. We cannot move any farther. So one of the answer will be minus 1 plus root 85 divided by 2. So this will be one answer. Another answer is, we will check if another answer is correct or not, of course. So this is for the plus value, okay, for the plus value, and for the minus value we will have another answer, which is minus 1 minus root 85 divided by 2. But I have to check if this answer is, my negative answer is valid or not. It looks like a little bit crazy. This one is root 85 equals to 9 point something. So minus 1 minus root 85 divided by 2. So we get 5 point something. Let me write it here, and I will explain what I'm doing here, or why I'm doing that, why things are going crazy here in this math. I'll explain that, don't worry. This value is minus 5.0, and this value is something positive, so we don't care about this thing. Now it looks like if we put it, okay, let's see if we put it here, is it positive or negative? Minus, so this is alpha x squared plus alpha x. I think this is what this works. Plus 4, calculate minus 5.1. I think this will work. Minus 5.1. Yeah, both of them works. Both of them work, so both of them are correct. What I have done here is, after finding this negative answer and this positive answer, I tested it. I have tested it here. I have tested it here. If by using these values, this becomes positive, this is still positive or not, because we have some obligation to keep it positive. Okay, so that is the reason why we have tried it. Alright, so answer of this question is this. Minus 1 minus root 85 divided by 2 and minus 1 plus root 85 divided by 2. In this case, negative answer actually it can absorb, because there is some x squared here, so it can absorb it. But in all maths, negative answer cannot absorb. Okay, let me show you. Okay, let me solve one more math, then I will show you where. I think let's show you the first. Let me show you where what is the problem if that negative number comes. Let me show you that. Okay. Yeah. So see, in this case, we have one of the situation where you got here. This is actually the case for the base. The case for the base, this one is. So we will have to look at all these things based on the conditions. So this is x log of x equals to 64 equals to 2. So when you do it, we get positive and negative for the value of x. But since we know that this this base has to be positive, this x has to be positive, that's why we need to discard this. We need to discard this minus 8 from here. This is the book that we are solving now. And all the concepts that we talk, all of them is here. Okay, all of them are here. The domain of the logarithmic function y equals to a log a base x is greater than 0. Okay, so you have some x is greater than 0 thing here. Do you understand? This is why I said that in our math, we try to keep it greater than 0. We try to keep it greater than 0. Do you understand? This is the reason. So that the condition fits. All right. So let's solve one more math so that another type. There is another type of math. That's why I need to solve it, or else you will be crazy. You'll be like, sir, what is this? You did not solve any math from here. How do we solve it? There is no log, there is no ln. What do we do? What do we do about them? These are crazily different maths, because everywhere there is log or something written. These are just only numbers. How do we solve it? How do we solve it? So you will say that, okay? Let me solve one of the math first. Which one? This is last one. People usually say that last one is the hardest math, so let me solve the last one. So the question is 4 e to the power x plus 1. This is crazy, you know, life is crazy, because I think this is my 10 time recordings, most probably 8 or 10 times recording this video today, because every time when we start the pre-recording, something crazy happens. Then I have to stop the recording, and then I have to restart it. You will not believe it. This is now, I think, 3:30 p.m. I guess, or around that, 3:30 p.m. I started recording this video in the morning. And in the meantime, of course, I took a shower and bath and had food, because something crazy happens, then I have to record it again. I mean, just for one video. Can you imagine it? And I actually, to be very frank, I actually started it last night. I don't know what is happening with this video. This is crazy. I mean, not only this video, when you do the pre-recording video, something crazy happens. All right, so 4 e to the power this. So how do we solve it? Something crazy means things comes here, some outside noise all of a sudden, people talk, or like someone is waiting in my door. I have to talk to them, and these people keeps me talking with them. And then I was like, this is not a good time. I'm in the middle of something. And yeah, all these things. So hopefully it will not crash into anything. What do we do in this kind of situation? We actually took a little break also, so that you also, break means we talked about something else, so that your brain gets a break, because these are different type of maths. When you see some different type of maths, always remember you have to switch your brain. This is like when you have to speak in English and speak in your mother tongue, you have to switch your brain mood, or else it will be slightly, annoying to talk. Our brain usually does it, our mind usually does it automatically, but if you do it consciously, you will feel good. So here, nothing is given. What do we do? First of all, you see, there is a number here, there is a number here. Mix them together. Then you will have e to the power x plus 1 equals to 5 divided by 4. Okay? So we have sent this 4 to the other side. Now you have e to the power x plus 1 equals to 5 by 4. And you know something funny, and that is you can multiply both sides by ln. And if you multiply both sides by ln, this ln and e will evaporate. This will go away. This will go away. This is like, fumes. Just it goes out, goes up somewhere. So what you have is x plus 1 equals to ln 5 by 4. So x equals to what? X equals to ln 5 by 4, give a bracket, minus 1. This is the answer. If you see e somewhere, then ln is your friend, ln is your soul, or something like this, by which you can handle this e. Okay? This is the technique, trick. Let me solve another one, last one for today's recording. This one. Similar, but there is no e here. What do you do about that? So, but something similar, you have a number, so send this number to the other side, then it becomes 10 to the power twice x minus 7, so it becomes 3 by 8. Now we have our another friend, and that is called 10 base log. One is common logarithm, another one is natural logarithm. Natural logarithm is when it is e base, natural logarithm when it is e base, like log e base. This is natural logarithm. Common logarithm is when it is 10 base. So we can bring a 10 base log here. See what we do. Now look, you have the freedom to multiply here also ln both sides. But that is not helping us. That is why we are not multiplying it. Okay? We are multiplying it by log 10 base, both side, remember, log 10 base, by the way, multiply both sides. Now this power comes here, so it will become twice x minus 7. This power goes first, then it is log 10 base 10. Same thing base same thing goes away, evaporates, kind of. Then you have log 10 base 3 by 8. I think now you can see what is the solution. So the next line will be twice x equals to log 10 base 3 by 8 plus 7. This 7 will go to the right side. Or you can add both sides 7. Then this 7 and plus 7 will cancel out. There will be a plus 7 in the right hand side. You have a 2 here, so you just send it in the right side, so it will become 3 by 10, 3 by 8, bracket close, very important, do not forget, this is divided by 2, this is the answer. You will not have to write it in the decimal, just keep it as it is, no problem. Okay, just keep it as it is, no problem. We actually have some application math here. So when you have like some function given, this kind of healing of wounds, this math actually we had in the exponential function also, we have them. This is like kind of when you have ln, when you multiply ln, then actually you can eliminate this e, then ln and e will be cancelled out. So this is n equal to what, you can easily find out from this kind of calculation. Okay, this calculation is helpful. This is helpful when you multiply both sides by ln. Okay, same process for this one. This is like how it helps. Okay, how it helps if we have the ln thing. How this calculation is helpful. When you have somewhere e, you multiply both sides by ln. Then e gets cancelled out. You get some number, and some variable. Just do the calculation to find it out. Things should make sense. Just have a look at how it works. Okay, how it works. Here it is 50. Here it is 50 because as the value it says here, if the healing is taking place after how many days, will the wound be half of the original size? So actual size is 100. Half of the original size is 50. Then 100 is here. This is the 100. E to the power this into n. You do the calculation. This is 10% of the original size. For the B number, 10% of the original size. So 10% of 100 is 10. That means here, instead of 50, in the B number, it will be 10. Then do the calculation. Same way, same process. Spreading of rumors. This is also some concept that we have seen in the exponential. Similar thing is happening here, this and this. Then you multiply both sides by ln to eliminate this e, and then we get the solution. Yeah, that's all. How many days it will take to spread the rumor. This is how it works. So when you have combined ln and e, log, exponential, all these things, you see math becomes easy. Things becomes easy when you understand these concepts here. So that's all for today. Thank you all. Thank you very much. Have a good day and see you all in the class. Happy math practice.